Have you ever tried to imagine the moment before everything began? Before the stars, before atoms, before time itself? A moment when even emptiness did not yet exist. It sounds like a paradox, doesn't it? How can we talk about before, if time itself didn't exist yet? And yet scientists don't look away from this question, because to understand where we came from, we have to peer beyond any conceivable beginning. When we say the Big Bang, most people imagine a cosmic firework, an explosion of matter into empty space. But that's an illusion. The Big Bang didn't happen in space. It created space itself. It didn't occur in time, it gave birth to time. That's why the question what came before confuses even physicists. But unreachable doesn't mean unknowable. Step by step, modern physics is getting closer to understanding what might have preceded our universe. To find the answer, we must go back to the earliest moment we can even describe, when the universe was smaller than an atom and the temperature reached 10 degrees. At that scale, our familiar laws of physics stop working. The realm is ruled by quantum gravity, where space and time fluctuate, and energy and matter are essentially the same thing. At this boundary, our theories break down. Einstein's general relativity explains the universe on large scales but fails at these densities. Quantum mechanics describes the microworld but ignores gravity. At the moment the Big Bang began, those two worlds collided. For a long time scientists believed that at the origin there was a singularity, a point in which all mass and energy were compressed to zero volume, with infinite density and temperature. But that's not a real state of nature, it's a sign that our equations stop working. Infinity is mathematics raising a red flag. It means we need a new description, something to replace that fictitious point, and describe how everything truly began. Below the Planck length there is no smooth space at all. Everything consists of quantum bubbles, brief flashes and collapses of energy. This chaotic foundation is called quantum foam. Perhaps our Big Bang was one of those microscopic flashes that didn't vanish but became stable. A bubble of spacetime that began expanding and turned into a universe. Our beginning, then, is not unique, it's one fluctuation among countless others that happen to survive. Another idea is eternal inflation. We know the newly born universe expanded at unimaginable speed, cosmic inflation. But why would that process ever stop? Maybe it didn't. In other parts of reality, inflation still continues, creating new universal bubbles. Each expands, cools, and becomes its own cosmos with its own laws of physics. Ours is just one in an endless foam of worlds. If that's true, the question what was before loses its meaning. Before simply refers to another region, another bubble where time and physics work differently. A different hypothesis speaks of a cyclic universe. The cosmos may not have a single beginning but live through infinite cycles. Expansion, slowing, collapse, and rebirth. Every cycle ends when matter compresses into extreme density, then space rebounds, and a new Big Bang ignites. It's not a beginning but the breathing of the universe itself. We might already be living in its 100th or 1000th cycle. Loop quantum gravity offers a similar view with more mathematics. At ultimate densities, gravity could become repulsive. Instead of a singularity, there's a quantum bounce. The previous universe collapsed, reached a minimum size, and rebounded. In that case, the Big Bang was not a start but a transition, a bridge between two epochs without an absolute beginning of time. An even more exotic possibility is the quantum tunneling universe. It might have appeared not from matter but through a quantum tunneling event, not from nothing, but from a state with no time and no space. There was no emptiness in the usual sense, because empty already implies space. There was only quantum possibility, a fluctuation that tunneled into reality like a bubble breaking free from a perfectly still surface. Another approach comes from Hawking and Hartle. They suggested that the universe simply has no beginning. Under the extreme conditions of the early cosmos, the boundary between space and time disappears. The word earlier loses meaning. Just as there is no direction north of the North Pole, there may be no before the Big Bang in any physical sense. At this edge science collides with human perception. We treat time as a line, past, present, future, but perhaps time isn't fundamental at all, perhaps it is an effect, not a cause. An illusion created by the changing states of matter and energy. If so, the question what came before cannot have an answer, because before did not yet exist. Physics at the brink of creation turns into philosophy. If nothing preceded our world, does that mean everything arose from absolute non-being? Or maybe nothing is a special condition in which all possibilities exist but none have yet unfolded. In that case, emptiness is not absence but potential. The vacuum isn't dead, it holds within it the rules from which everything can awaken. This paradox forces us to rethink existence itself. We believe every effect must have a cause. But if the universe had no beginning, it needs no cause. It simply is, as a mathematical truth is. We don't ask who created the number 2, it just exists. Perhaps the cosmos does too. Why does this question matter? Because the answer defines our place in reality. If the universe had a beginning, then it has a story, maybe even a purpose. If it didn't, everything exists in an eternal present, and meaning lies in motion, not destination. In both cases, humanity is the bridge through which the universe becomes aware of itself. What we can actually see is the cosmic microwave background, light left over from when the young universe first became transparent. It's almost 14 billion years old, a snapshot of the cosmos as an infant. Its fine structure shows extraordinary precision, slightly different values, and there would be no galaxies, no stars, no life. That stability hints at order rather than accident. Some modern observations show strange circular patterns in this relic radiation. A few researchers think they could be scars left by collisions between our universe and others. During the inflationary era, proof is lacking, but if confirmed, it would be the first real evidence of what existed before the Big Bang. If that happens, we'll know we're not a one-time event. Our cosmos would be one generation among countless others, each leaving a faint echo in the next. A grand respiration where life is how the universe observes its own evolution. All our theories agree on one point. The Big Bang was not an explosion of matter but a transition, the birth of time itself. Out of a timeless state came space, movement, energy, and eventually life. In a sense, we are still living inside that expansion. The Big Bang is not over, it's happening now, in the unfolding of galaxies and in the fragile heartbeat of time. So what was before? Perhaps another universe, perhaps many. Perhaps only the silent quantum background where everything and nothing coexisted. Maybe the question what came before the Big Bang will never have a classical answer, because the very concepts of before and after appeared only with time. And yet humanity will keep asking, because the need to understand origins is part of who we are. As long as we ask this question, the universe evolves through us, using our curiosity as its own instrument of awareness. Future telescopes will look deeper than ever. But even when they reach the final limit, beyond it will still lie silence. The same silence from which everything once emerged. Maybe that silence is the answer. To search for before is to be alive. And perhaps none of our theories matter as much as the single fact that matter itself has learned to look back at its beginnings and wonder whether there was ever a before or whether everything truly began the moment we first asked the question.